This week I worked on a batch of problems for section 4. I had already read the section June 10, but for June 14 I have attempted the first 25 problems of Gallian section 4, 7 of which are proofs, and I'm up to 116 proofs. Yeah, and I think I'm going to change this 25 to be the total number of problems, but I didn't do that this time. Okay, so then for the book, as I mentioned last time, I believe I did, it was cyclic groups. Yeah. Let me see. Yeah. So Gallian starts with the integers, where the generator is either 1 or -1. You can multiply any number of negative ones to get all the integers, or the same for ones. And by multiplying, this means either negative values, 0, or positive values. That's how you cover them all. Then some examples. Then, of course, U8 is fully non-cyclic because you cannot find any one of the subgroups to be cyclic. So as soon as you get just one subgroup to be cyclic, then the group is named cyclic. So that happens to be the case for U8. But most of the U groups are cyclic. You can always find one that does cover the whole group, but not necessarily, as this example tells. Then some theorems about how to compare for cyclic groups, different generators and different subsets of the group. Then, of course, then how to look at the order of A and B, and then the order of the term AB in the KD table. And what's really interesting about this section is that I need to look at my number theory, but I believe that the same methodology that is used to find all the generators of a subgroup in one of the cyclic groups is that one used to find primitive roots in number theory. I seem to remember that that's how it's done. And the clue was this equation right here, n over GCD over n of nk. To let A be an element of order n in a group and let k be a positive integer, then the generator A to the k is the same as the generator GCD nk, and the order of A to the k is the same as the total order of the group n divided by the GCD of that order and the k value. Yeah, so some examples that definitely remind me of primitive roots in number theory. And then, of course, the fundamental theorem of cyclic groups, the main theorem in the section, and the Tottian function from Euler, which again, number theory, you get to use that a lot. And finally, this is the first time in Gallian where these diagrams, the subgroup lattice diagrams, come out. And I've attempted up to 25 for this, but I've already done some more. Yeah, actually, I'm up to problem 60, but I haven't graded them. So, yeah. Then on to the work itself. Yeah, this was all the latter part of section 3. The last problems of section 3. Yeah, I guess I'm going to have to title this video to include section 3. I did forget to mention that I did do the tail end problems in section 3. Yeah, some proofs for SLR2. Multiplying two different roots of unity gets you unity. Yeah, these are the last problems of this section. And so this means that I attempted every single one of them. Yeah, not as well as I should have in some cases, but yeah, I did this one right, even though I thought I hadn't. Yeah, then reading of section 4. Of course, I always like to calculate myself. There is an error in the book. Yes, I just remembered. There is an error in the book. It's not a major one, it's not a big deal, but here, right here, was it in this one? Yeah, right here, the GCD of 1,185, that's wrong. There's a 37 in there instead of a 17. So they actually calculated, this is the GCD with like 340. Let me see, 420, yeah. 2 to the 2 times 5, yeah. So actually, and in my notes you'll see it. Yeah, in my notes you'll see it. Let me show it where it is. Oh, here it goes. Yeah. So in the book, A185, the GCD should be 5. And then what they actually calculated is the GCD with 340, which is 20. Yeah. Don't know why they did that, but it's not 17, it's 37. Then some more reading. Taking a group and then breaking it down into all the subgroups. So if they give you the order is 30, take out all the different ways in which you can get 30 and write out all those subgroups and then write out all the terms. And of course, because it's a homeomorphism with the integers, then you can do the same thing and it's really Z30. And then this would be, instead of a square, it would be E12 and E15. And E would be 0 actually in the integers mod numbers. Yeah, and here's an example. Of course they do that. Yes. Then for the problems, the calculation problems, pretty straightforward. Yeah, and of course they ask for an example of a group where all the subgroups are non-cyclic, right out of the Texas U8. But I could have mentioned D3 and I did not. That's, you know, that's a nice thing that I need to remember. And then I thought I had figured out this formula for, you know, M, generator of M, intersection generator of N. What is it? I thought I had it, but it's not like that. And I looked at the answers and it wasn't like that. Yeah. Then I have a sheet where I do like answers for when I mess it up. But luckily, I really didn't mess up that many. So I have some space left over. Yeah, I got this right. Just more subgrouping. And I got this also correctly. Just subgrouping the integers. Just do the generators. You gotta go negative and positive is, yeah, both. This is actually written wrong. It really should be -2 is the same as 2. Yeah, it's the same. And then I did not mention theorem 4.4 in this problem, and I talked too much about it when I compare it to the answer, but yeah, it's correct. It's what the answer says. Yeah, so that is this week so far for section 4 of Gallian.